Okay, so in this tutorial I want to explain the solution to this question. Okay, even though they have a memo, but they did not explain the solution, they just gave the solution. Okay, so this is the question, this is the solution, okay, for the question which was asked on this thing, the November 2023 physics paper 1 exam. Okay, so they say a ball is dropped from a height h. Okay, so a ball is dropped from this height. Okay, this is the height in which your ball is dropped. Okay, then when they drop this ball, they drop it with the momentum p. Okay, when it strikes the floor with the momentum p. Okay, so momentum, so this is momentum p is equal to mass times velocity. This is how you calculate the momentum of an object. Okay, it's mass times velocity. Okay, now they drop the same ball. Okay, which means the mass is still the same. Now they drop the same ball. Okay, but they drop it at a height which is half of that height. So if this height was 10 meters, then now they are dropping the ball at a height which is 5 meters. Okay, but they did not say the height is they did not say the original height is 10 meters. I'm just saying because I want to explain what half h means. Okay, for those who don't understand. Okay, now they're dropping the ball at a height which is half of that height. Okay, now they want you to find the momentum. Okay, if the momentum the ball is struck this ground is p, what would be the momentum when the ball is dropped at a height which is half of the original height? Okay, so this is what you need to understand before you attempt this solution. You attempt this question. If I have a ball at this height, okay, it does not matter what height it is. Okay, as long as the ball is high. Okay, so the ball has got an energy EP. It has got an energy which is due to its position. This is the potential energy. This is the energy that is possessed by an object due its energy. Okay, due to its height. Okay, then when a ball starts moving, okay, so this is your ball. It's moving to the ground, moving towards the ground, moving towards the ground. So when your ball is moving, then now it has another energy which is EK. Okay, but because okay, so EP is equal to mass times gravitational acceleration 9.8 times height, then EK is equal to half times the mass of your object times the velocity squared. Okay, so these are your two energies. Okay, so now because due to the law of this thing, the law of conservation of energy, we cannot create and we cannot destroy energy, but we transform energy from one state to another. Okay, so we have potential energy. Okay, which means this kinetic energy that we now have when the ball is being thrown down and the ball is moving is the same. So it should be equal to that potential energy because we can't create another energy. So it's basically this energy being transformed to kinetic energy. This is why we say, okay, this potential energy which is mgh is equal to this energy half mv squared. It's just that it's the same energy but in another state. Okay, in another form. Okay, so since we need to know v in order to find p, we need to know v in order to find momentum. So let's try and solve this equation for v. Okay, so the first thing that you could do, the first thing that you could do is, you can divide by m both sides. Now you'll be left with gh because these m's with this will cancel when you divide by m both sides. Now you have gh. Okay, now you have gh is equal to v squared. Obviously you have that half, but in order to remove the half, multiply this equation by 2. So when you say 2gh times 2 is equal to 2 times half v squared, then this half will cancel. So now you are left with 2gh is equal to v squared. Okay, so first thing you need to do, you divide by m, then you multiply the equation by 2. So 2 will remain on this side, but 2 will cancel with that half because when you say 2 times half, this will give you 1. There's no need to write 1. Okay, so this is how I remove this half. Okay, now we're solving for v. So we have our v squared, so we need to take the square root of v. So we get v is equal to, so take the square root of this side, is equal to 2gh. Okay, is 2gh. Okay, but now we want to find the momentum. So we want to find the momentum is equal to velocity times mass times velocity, which means we need to multiply this thing by mass. So it's m times v, then we need to do the same to the other side. So it's mass times this thing which represents the velocity, 2gh. Okay, this thing is the momentum. So this is the momentum at which this is the momentum of this ball. Okay, when it's dropped at height h. Okay, this is the first momentum. Okay, so I represent this thing. This is p. Okay, this is just p. Okay, but now once calculate the second momentum, I will represent it with p prime. Okay, so you wanna find p prime, which represent the momentum of this ball when it is dropped at height, at a height which is half. Okay. Okay, so now we have this equation of the momentum. Okay, we have this equation of the momentum. Now, okay, now you wanna use it. This is the momentum of the ball. Okay, when it's dropped from height h. Okay, it's 2g. But now we're dropping the ball not at height h. Now we're dropping at a height which is half of h. So we're dropping at h over 2. Okay, so it's 2g times h over 2. So these two will cancel. So it's p is equal to, okay, this is, okay, since now it's not, okay, since now the height has changed, it's no longer the momentum of this ball at this point. It's the momentum of this ball. So I need to represent this momentum with p prime. Okay, because it's this ball which is dropped at a height of h, at a height of half h. So the p prime is equal to, okay, p prime is equal to, okay, it's equal to m square root of, okay, square root, okay, so 2g times h over 2. So 2 and 2 will cancel. Now we are left with, okay, now we are left with gh. Okay, because 2's will cancel. Okay, now this is what we have. Okay, so this is the equation of p prime. Okay, now we have this equation. Okay, we have this equation. P is equal to, this is the equation of the first momentum. Okay, is equal to m. Okay, maybe I should okay, so this is equal to m. This is the momentum p when the ball is dropped at height h, the first drop. Okay, so now it's equal to m times the square root of 2gh. So now, okay, so now we can take out this root 2, but because root 2 is not squared, we cannot remove the square root. So root 2 we can separate the square root, but you can't take the 2 out of the square root because it's not squared, which means now you have the square root which only contains gh. Okay, now when you look at m and gh, they are being multiplied together, so this thing they equal to this momentum p prime. So p is equal to, so we can represent mgh with p prime. Okay, so now we have square root 2, which is not part of p prime. Okay, now we are solving for this momentum p prime, which is this momentum we're solving for. Okay, so p prime, you can divide p by, is equal to p, the original momentum, divided by square root 2. Okay, so this is the same as a half, is the same as 1 over root 2 times p. Okay, which is solution to 1 over root 2 times p. So this is how you solve this thing. You need to understand the basics of potential energy and kinetic energy and the relationship between height and potential energy. Okay, so I hope this video is clear.